Part of the freediving experience is the physical conditions of water that affect your body. You need to understand how water affects pressure, light, sound, and heat to understand what's happening in your body and how to avoid certain problems. Right now, you are under pressure caused by the weight of the air in the atmosphere. At sea level, the pressure is 1 bar or atmosphere. Water adds pressure. 10 meters, 33 feet of water equals the pressure of the atmosphere. So, at 10 meters, 33 feet depth, the pressure is 2 bar or atmospheres. 1 from air and 1 from water. This relationship continues for each 10 meters, 33 feet. 3 bar or atmospheres at 20 meters, 66 feet. 4 bar or atmospheres at 30 meters, 99 feet, and so on. Pressure doesn't compress liquids, but it does compress gases. Gas volume varies inversely and proportionately with the pressure. If we double the pressure by going to 10 meters or 33 feet, the volume compresses to 1/2 what it was. Triple the pressure at 20 meters or 66 feet, and the volume's 1/3, and so on as you go deeper. It works the other way, of course. If you take a gas volume from 20 meters or 66 feet to the surface, for example, the pressure is reduced to 1/3 and a gas volume triples. Your body is mostly made of water, which doesn't compress, so you only feel pressure where you have compressible air spaces. We'll return to this shortly when we discuss equalization and some other effects. Pressure also affects how gases dissolve into your body and how your body responds to gases in a mix of gases. Increased pressure makes more nitrogen in your lungs dissolve into your body tissues. When you surface, not as much can stay in solution, so it diffuses out of your tissues. This is the underlying cause of decompression sickness, the bends, in diving. So it's a potential concern for free divers who are also scuba divers. Don't participate in recreational open water or constant weight free diving after scuba diving on the same day. Scuba diving after free diving may have some risk, though it is likely low. It's rare, but serious free divers can accumulate enough excess dissolved nitrogen to get decompression sickness apart from scuba diving. It's possible by many deep free dives in a short period, or many frequent, moderately deep free dives for an extended period. To reduce the risk, allow ample time between dives, especially deeper ones. The deeper your dives, the fewer you should make in a day. How your body responds to a gas usually relates to the pressure of each gas, not the percentage. We call the pressure exerted by an individual gas in a mix of gases its partial pressure. If you increase the pressure, the partial pressure increases even though the percentage stays the same. Here's an example. Air is 21% oxygen, so at the surface, the PO2, partial pressure of oxygen, is 0.21. If we free dive to 10 meters or 33 feet and double the pressure, it's still 21% oxygen, but the PO2 doubles to 0.42. Now, suppose we have a gas mix with only half as much oxygen as air, 10.5%. That's not enough at the surface. But at 10 meters or 33 feet, the partial pressure doubles, making PO2 0.21 the same as air at the surface. So at 10 meters or 33 feet, this gas mix has ample oxygen for your body's needs. Go to 20 meters or 66 feet, and even with only 10.5% oxygen, the PO2 is higher than with air at the surface. We'll come back to this principle when we discuss how your body uses gases when breath holding at depth and what can cause you to black out as you ascend. Water affects how we see underwater. First, it magnifies by about 1/3, so that something looks closer or larger, depending upon your perspective, than it really is. Second, water absorbs color, first red, then orange, yellow, green, blue, and violet. The deeper or farther light travels, the more light lost. But your brain and eyes compensate for this somewhat, so you still see a lot of color underwater. Particles in the water block and scatter light. This affects how quickly it gets dark as you descend, and how far you can see. When you descend from the relatively bright conditions at the surface, it can seem darker until your eyes adjust. The more particles in the water, the greater the brightness difference, and the darker it will seem. Water transmits sound faster and farther than air does. Our ears determine sound direction based on the differences in time it takes for a sound to reach each ear. But traveling 4 times faster underwater, sound reaches both ears about the same time, making it hard to tell its direction. Most sounds seem to come from all around directly overhead, though they may sound louder and closer than in air. Water absorbs heat faster than air does, and it holds more of it. A temperature that's comfortable in air, 21 degrees Celsius or 70 degrees Fahrenheit, for example, quickly feels chilly in water. Wetsuits reduce heat loss, so you're comfortable longer. At moderate temperatures, about 25 degrees Celsius or 78 degrees Fahrenheit, with the right wetsuit, most people can stay in the water indefinitely. You'll learn more about wetsuits when we look at free diving equipment.